In this video, we'll be discussing the implementation plan for Canon 2. Now, I'm sure everyone remembers the requirements of the Canon game, so we're not going to go back over them. With them in mind, we're just going to move forward with our implementation plan. So let's go ahead and bring up a whiteboard and start talking about it. So the first thing that we plan to do will be to create our game item class, because the game item is, in a sense, the center of the whole thing. We're going to have a game engine that's going to be working with game items. Without game items, we don't have anything on screen to move around or to interact with, right?
Exactly. The game item is what is going to represent any movable object inside of the game.
You got it. So, game item, that's all caps, I promise, class. So we'll start out with the creation of this. Now, what does the game item class contain? Well, Logan and I talked about it for a little while, and we tried to make it as simple as possible. We just wanted it to contain things like, where is it currently at on the screen? If it is something that can move, how fast is it currently moving? And since we're still having to deal with picture boxes, what is our associated picture box with this particular game item? Speaking, of course, of a game item in the sense of it being instantiated into an object. Okay? So, let's go ahead and jot down 3 data members that we're going to need. We're going to need a position, a velocity, and some sort of reference to a picture box. So, some simple names. Position. And position we decided to be of type point, because that makes loads of sense. That will give us an X and a Y coordinate. We also decided to use a velocity, since that made sense. And again, a type point. How many pixels will we be moving in X? How many pixels will we be moving in Y? And then finally, we decided to call our association with a picture box texture, only because when we get over into XNA, we will be working with textures. We're no longer going to be working with picture boxes.
Right, it's just in this version, since these different versions of Canon are meant to be basically the same game, the idea is that game items have a texture. It's just that in the WinForms one, we're not going to get into Windows drawing of textures, but we have the convenient picture box sitting there, so that will be our association and how we represent the texture for this game item. In Windows, we use the picture box.
That's right. When we get over to XNA, we will use real textures. Okay, so these are data members. So our 3 data members. And in our implementation, Logan and I decided that we wanted these to be private. We did not want the engine to be able to get its fingers into here and touch these particular variables, okay? They needed to get to these variables through properties. So we're going to have properties for each of them. So let's go ahead and start talking about our properties. So let me just kind of draw a line up under here just to separate stuff. So of course we're going to have a position property. Pop quiz. Does everybody remember how we're going to be doing the naming? That's right. The convention will be using the same word except with a uppercase letter at the start. So position will be matched up with, just as a reminder, position above. I can just barely get my mouse over here. There we go. And the only difference is, of course, going to be a capital P instead of a lowercase p. That is a lowercase p, I promise. Okay, so position, we're going to have velocity. We're going to have texture. Then we're going to have one other property that will not be associated with a data member. Instead, it's going to have its own particular job, and it's going to be the origin. While I'm writing this out, Logan, what does origin do?
Well, origin is going to be something that will give us the center of the texture that we're currently using for our picture box, or the center of the picture box that we're using as a texture.
Okay.
And the idea with that is that way we have one convenient place where we can get the center instead of having to have an external method like we did in Canon 1 where we had the get center method.
Okay.
Now this is going to be a little bit different than get center, where get center got an actual screen position. This is going to get the position of the texture with the texture being the only thing in mind. This isn't going to give a screen coordinate.
So relative 0, 0, if you will.
Exactly. This is going to be relative to this game item.
So if our particular game item just happened to be 32 by 32, it will simply start at 0 and treat it from 0, working its way over and again 0 working its way over and get that information.
And give us the center of that picture box.
And then we can, of course, use that information later on some other way to determine where an item needs to go on a screen, dealing with screen space now and appropriate offsets.
Right, that way position will represent the center of the item. So if we did a distance check or we needed to have one object be in the same position as another object, they would be centered on each other instead of having this weird top-left offset.
So in this particular case, origin is simply going to give us information. So that means we can set it up in such a way that it's a read-only property.
That's right, especially since it does not have any associated data member. We wouldn't have anywhere to put data if we had made it writable.
That's right. Now with these guys, they're all 3 read and write. Make sense?
Right, because we
can set it, and we can read what we just set.
Right, when we set it, it goes into the data member. When we read it, we get data back out of the data member.
There you go. Okay, so finally, that takes care of our properties. Moving right along, our member functions are going to be update and draw. So let's go ahead and add those real quick. And Logan, while I'm writing these out, update, what does it do?
Update just takes in it takes account of the current position and velocity of the game item and updates the position based on the velocity. Okay. It doesn't take in any information. It's just something that is called for this item and allows the item to basically move on its own. It looks at its own velocity and sees how much it needs to move based on that velocity. Okay.
So it doesn't interact with anything in the outside world.
Right. It's only looking at itself. It's saying, all right, how much do we need to move based on our velocity?
It's just, well, basically it says, here is our, if I find, there we go, here is our position, here is our velocity. Let's go ahead and derive our new position based off of our current position and velocity.
That's right.
And that is all, and that's updating. It's updating that particular item. Now, draw, on the other hand, is going to set the location of our texture. Now, let's think, what does that actually mean? If I say it's going to set our texture, it is going to, so here's texture. That means we're actually talking about setting the location of our picture box in this implementation of Canon. So what am I saying? We're simply going to control where we're putting the picture box on our screen.
Right, since drawing is handled more or less by a picture box, it's not so much that we're drawing the pixels inside of that. Instead, we're just moving that picture box to where we're currently at. It's kind of like drawing the scene in the sense that moving the checkers on a checkerboard is drawing the state of the checkerboard.
Exactly. And these, of course, as with properties, will be public. And why is it going to be public? Well, we need to be able to access this from outside of our game item class. All right? And same, of course, goes for properties. They need to be public because they need to be accessed from outside of the class. Otherwise, well, we'd be in a world of trouble, wouldn't we? We'd just seal ourselves off. We don't want to do that. Right. Okay, so this will be our game item. This is the first thing we need to do. It's going to be a very simple class. Let's go ahead and bring up another sheet of paper real quick. I love how I'm calling these sheets of paper now. All right, the next thing, we're going to start writing our engine. So let's just go ahead and jot that down. Loads of stuff that we need to do. Now, while we are recreating the game, we will be borrowing parts from Canon 1. There's no reason to code parts of Canon 1 again if it's identical or almost completely identical, right, Logan?
Right, in cases where, well, what happens when you die? You lose a life. And all that is a matter of decrementing a variable. All that code can move over. It's almost outside of the world of the engine. It's something that the engine will use, but it is still something we have to do at some point, engine or otherwise.
Exactly. So we'll start off a new project. We'll have our, well, I mean, actually, we've already started a new project, but we'll actually turn our attention over to our form designer, and we'll start out by dropping in our picture boxes. So we're going to have a player, and I'll go ahead and write out the first one. This is what we're going to call it. This is what we decided.
Right, just be overly explicit on the naming so that when we have a player picture box on the form, and then we have a player inside of the game code, those two don't get confused.
Silence is just killing you guys, isn't it? Okay, So basically, like I said, with each of these, well, let's go ahead and try to deselect that as I managed to hit buttons over here by accident. So we're dealing with a target picture box, that'll be its name, a projectile picture box, a lives display picture box, and a title screen picture box. So we'll create all of these objects, and then we're going to add 2 timers because we want to go ahead and decouple the update and the draw so that what we have here in Canon 2 is very, very similar to what we're going to have when we get over into Canon 3 inside of XNA. So we're going to drop down an update timer, and a draw timer. Think you can figure out what they're going to draw? Or draw. Think you can figure out what they're going to drive? See, I wanted to say drive, but the D, and it all came out as draw. Okay, so once we get that in place, the next thing we're going to do is some variables, and we're going to copy, well, pretty much all of these over from Canon 1. So I'll just put variables down, and just mention them. We're going to be bringing over our constants, our screen width, our screen height. We're going to bring over the projectile speed, base target speed, collision distance. All of this should be familiar to you by now. We're bringing over our starting lives, game difficulty control, our lives title width. We're also going to bring over is game running, lives, and level. Of course, those are not constant. And also, we're going to bring over our random as well, a random variable.
Right, those are all the variables that are going to be exactly the same in this version of Canon.
Exactly. So let me go ahead and start breaking some of this stuff up here, just so that we can see that this is indeed different sections. After we get this in place, next thing we're going to do is we're going to skeleton in the engine methods and one of the mechanics methods. So we're going to skeleton in skeleton methods. And they're going to be initialized. Tell me if these look familiar or not. Load graphics content. Update scene. So again, as I mentioned in the last video, we had to change the naming just a little bit. And draw scene. And in case anyone's already forgotten what I talked about, what do you mean by changing the naming? We added the word scene to the end of these just so that we have no conflicts going on inside our WinForm application. So they're going to be called update and draw. That's going to be given to us automatically over in the XNA framework. Here we're going to call them update scene and draw scene. Okay? So once we get these skeletons in, we're going to go ahead and do one of our mechanics methods as well. We're going to add in our update player. All right, and this is going to be the method that's going to take care of pulling our mouse position and updating the player's location. All right, so from there, now let's go ahead and bring our attention up here. See if I can keep this nice and tight. And let us continue with our implementation plan. Once we get all of this in place, then it's time to go ahead and set our form client size and call to initialize. So we'll say client size and call to initialize. There you go. I'll just call it init. We get the idea. Then what we're going to do is set up our call to the load graphics content, just to speed things up, from within the form load. And this makes sense, right? The form is loading, and we can at this point call our load graphics content to handle loading in our graphics into our picture boxes.
Right, it also simulates a little bit closer the way that XNA itself works, where, I mean, one thing we could do, we could just call load graphics content from within initialize, but you don't generally do that in XNA.
Right.
In XNA, the framework itself calls load graphics content for you. We're trying to set up a similar scenario. In this case, the form load calls load graphics content for you.
Precisely. From there, we're going to go ahead and set up our calls to both our update scene and draw scene from the timers. So call update scene and draw scene from our timers, or from the respective timers, if you will. Okay, and then from there we need to go ahead and make sure we create the random object, and we're going to do it in initialize. So in initialize we will create our random object. Boy, hopefully nobody skipped videos, huh, Logan? Because if they skipped some of the earlier videos dealing with Canon 1, at this point it's going to look like they're just creating a random object? Well, yeah, it's a random object, but it's of a specific type, random, a particular type of yeah, there you go.
Now create a random object of your choosing. Okay, now continue on to the real code.
And we're going to create this in initialize. All right, from there we're going to focus on the player item. Okay, what are we going to do with this? Well, this is where we're basically going to get everything involved with creating the player game item and making it work, just so that we can see a very beginning iteration of our game in progress. So I don't even want to say it that way. Let me find another way to put it. To see the basis of our engine running.
Right, exactly,
like
so that we can see the engine running before we code in a lot of game rules and projectiles and targets and so on.
Exactly. So what's involved here? Well, we've got the player item variable that needs to be created.
I think that's just an old note. I think that's going to be,
it's going to be
a player.
It is. I already know that. So.
It's a player item variable called player.
That's right. So player, and it's the player variable. Logan's looking at my notes here, kind of panicking. Don't worry, I understand what I'm doing. I think. No, just kidding. All right, then what we need to do after we go ahead and set up our player, we need to initialize it. If I can spell. So we'll initialize it. From there, we need to load the image. Into the player's picture box. Okay, then what we need to do, this is very important here, we need to link, this is where we're creating that association. So we need to link up our picture box. Okay, remember, we have that texture data member inside of our game item. This is where we create the linked up, or the association, if you will, of a picture box to an object of type game item. Okay, so then we need to, after we get this linked up, we need to go ahead and call update player. In update scene. So that we, remember, basically need to make sure that we set our information, right?
Right, well, this is for when the game's actually running. We need to call update player to alert it to the fact that, well, we've run another iteration of the game, so we need to take velocity into account.
Right, and set.
And then set our position accordingly.
And then finally, with it set, then what we need to do is locate it, which we're doing with draw. So we'll do draw in draw scene. Okay, so we'll be calling upon draw in the draw scene method. And this is, in this particular case, we're actually going to be physically moving the picture box to our new position. So up here, we're setting position of our game item. Now, that doesn't move anything physically on the scene. It's just a piece of data, if you will, an encapsulated piece of data with some functionality, an object. But it is associated with a texture box, so in draw scene, or excuse me, a picture box. So in draw scene, now we take that picture box that's associated and we physically move it to the information that's contained within our object.
Right. In essence, moving all of the game items around on screen to represent the current state of the current scene.
Exactly. Boy, I'm sure some people are going, what? It's going to make a lot more sense when we start coding it out. So move picture box. All right. And of course, we need to make all of this work, we've got the call the update player right here. So hang on, there we go. So call update player from inside of update scene. So that means we're going to need to go ahead and code in update player.
Right, because up until that point, that call is just a call to the empty method.
Right.
And like you were saying a second ago, the goal of this is to see the player working in the engine, so of course we're going to have to code in update player.
Right. So right now you might be thinking, oh boy, you know, Buzz, I'm still new to all this coding thing and all, and the implementation plan just felt a little more simple when we were dealing with Canon 1, and now, wow, it feels a lot more confusing right here. Well, we're getting away from the way things were designed in Canon 1, which was very straightforward. Because our game that we're putting together, to be honest with you, is so simple, it would run just fine on a basic event-driven game or event-driven model, right, Logan?
Right, because, I mean, everything was right there, it was laid out in front of you, and it was only 3 things.
That's right. Now we're trying to move over to a framework that can, well, drive much more sophisticated games, but we're getting our very, very simple game up and running in it. And because there's now so much other stuff going on, it may start looking confusing real quick. Now, by the time we get to this point, this will actually be the end of video 2 of 6 different videos. We've got a ways to go. But by the end of this one, we will actually be able to move our mouse around and see our player truly moving. And it's not going to be moving because of events being fired from the mouse move. Instead, we're going to have the player moving because we're actually polling the mouse, finding out what location our cursor is at, taking that information, updating our game item, and then turning around and drawing the game item, which is really saying, look, take the picture box and locate it according to the information that's stored within game item's position, right?
Right.
And this is what we need to do to get to that point. So again, a real quick recap before I tear off another sheet of paper and start talking about the third video. Implementation plan begins with, after we get our game item class done, we then come back over to our form designer. We drop in our picture boxes. We name them appropriately, player, picture box, etc. But the key here is we have the word picture box in them so that we can identify and code what we're dealing with. From there, we're going to turn around and we're going to drop 2 timers in. We're doing this to decouple the drawing and the updating of the scene. Please keep in mind, updating the scene, the idea of that is that we are updating the state of the items within the scene. Drawing handles the actual drawing or the rendering, or in our particular case, mimicking rendering by simply moving objects around. From there, we're then going to move over to Canon 1 and grab all of our variables and move them over. And if I can find, my mouse actually managed to go off screen. Wow. So we'll grab all of our variables from Canon 1 and simply drop them in so we don't have to do all that typing. Then you guys have all become comfortable with us skeletoning in methods. We're going to skeleton in initialize, load graphics content, update scene, and our draw scene. All of these are going to become very familiar to you as you use them over and over and over in your career with XNA. We will then also add in our first mechanics method, which will be the update player, because we will need it to get to the end of this video and have our player moving around accordingly. From there, we need, of course, to go ahead and initialize our scene, set our client size, call initialize, call our load graphics from form load, call our update scene and draw scene from timers, and create our random object. Hopefully, you're kind of seeing what's going on right here. From an implementation point of view, if I can get that word out, what we're trying to do is basically set up all of our base calls that we need to do. We know we need to set a client size. We know we need to call initialize. We know we need to call the load graphics content. We're not putting anything in there. We're just calling upon it at the appropriate spot from within form load. From there, we know we need to call update scene from within its timer, and we know we need to call draw scene from its timer. And then from there, we know we need to have a random object because we know we need to randomize the direction in which our target object is going to fall from the sky.
It also kicks off the practice of creating objects within initialize.
Precisely. And then from there, we're ready to go ahead and focus on the player by getting the player variable set up, initializing it, loading the image into its associated picture box, linking that picture box up with it, and then calling the update player method from within update scene and calling our draw method from within draw scene so that we can within update player, go ahead and make sure that we set our game item's position accordingly based off of its velocity and all, and within draw scene make sure we move its associated picture box on the scene. And then, of course, we need to make update player work by coding in that particular method. So this, again, is going to be video 2. When we get that done, we'll have something that we can look at, which is always a fantastic thing. Let me go ahead and pull up another whiteboard because we have yet more to go. So we'll come back in here, not another whiteboard, but another screen. So we'll turn that off and just add another one real quick. All right, from here we're going to move on to another video which we'll title Mechanics. And from within the mechanics, the first thing we're going to do is, again, skeleton in some methods. So what are we going to be skeletoning in? Well, we're going to break this up again into 3 different categories. We're going to have mechanics methods, we're going to have collision methods, and we're going to have utility methods. So in our mechanics, so within this category, we're going to have, a lot of this is going to look familiar, check fire. That is an I in there, I promise. So we're going to have check fire. We're going to have reset target. We're going to have reset projectile. We're going to have check ground collision and check air collision. Now, Logan, we've actually got these broken out in 2 different areas here. This is on Logan's notes now. Or do we want to just skip this and move to here?
I would just skip and move on. I think that was originally set up as a skeletoning in and coding in 2 separate sections.
I gotcha.
But
right.
Yeah, those are collision.
Okay.
Only.
I just saw that written twice, so I didn't know if there was a particular reason you had that up there. So here we've got collision. So scratch what I just said, it just goes right under here. So within collision, of course, we've got our check ground collision. And of course our check for air collision. And then finally, our utility methods, it's going to be simplified this time around. Utility methods will consist of only distance. Alright, so once we have these guys skeletoned in, what we're going to do then is go ahead and turn our attention over to our target item. So let me just go ahead and I'm just going to write target item. And I'll push item way over here because it's just going to be our target. And we need to do things like, I'll keep this simple, we're going to need to initialize it. We're going to need to do texture. We need to update it, and we're going to need to draw it. Think about it. It needs to be initialized, well, create it. It needs to have a picture loaded into its picture box. It needs to know where its position is going to be set at for the game item itself, the target item, and then it needs to have its picture box drawn based off of where its game item's position is set at. Okay? So we need to go ahead and get all this coded in, and now since of course we're dealing with our target item, what else do we need to do? We need to go ahead and code in reset target and check for ground collision. Alright, at this point, things are really going to start moving around nicely. Now let's go ahead and just bring our attention up here.
You know, thinking about it, one more thing, if looking at target-specific stuff.
Sure.
After we code in check ground collision, we'll need to call that from update, much like we do call the
very good.
I'll just update for the item itself.
Call from update.
Because this will have the method just kind of sitting out in space by itself.
And you know what will happen, too? Since we're actually following our implementation plan while we code these, we'll actually code it out, because we do this always, ladies and gentlemen. And then we'll say, all right, let's go ahead and run the game and check it out. Hey, why isn't it working? And then we'll say, oh, yeah, that's right, we forgot to call it from, oh, yeah, because we always create these methods and we always forget to call them. It's funny when we do that. So you're absolutely right. As a matter of fact, guys, I'm going to write this down on the true implementation piece of paper that we're going to be using in just a few minutes. So call from update. So there you guys get to see us changing our real-world plan of attack. How cool is that? And then from there, the last thing we're going to do is focus on our projectile item. With the same type things. Again, we need to initialize it. We need to load the proper texture into the picture box that belongs to the projectile item, game item. We need to update it, basically set the game item to its appropriate position, and then finally we need to draw it, which means we need to take the picture box that's associated with the projectile game item and locate it in the proper place on the screen based off of the projectile game item's position. I just keep saying that over and over and over with each of these items, hopefully driving in what we're doing here. Because there really are two different things that they're dealing with. When they deal with, if you don't mind, I'm gonna just do a little bit of writing down here for a second. I mean, when we think of projectile, we're really dealing with two different things. We've got a game item, and we've got a picture box. Isn't that right, Logan?
That's right.
So we got a game item, we've got a picture box, and we do have an association here, and this association, if you guys recall, is through texture. But as the game is running, it is the game item's position .x and .y that we are setting based off of its contained velocity. But then we use this information through draw and actually set the picture box to that specific location. Does that picture kind of make sense, Logan?
Right. What that means is that the game item itself, if we have a game item for projectile, it has a position, but that doesn't correlate to anything visual.
That's right.
It's really just two numbers.
None of this is visual. None of this is visual. This is just an object that exists. It's just encapsulated data and functionality. That's it. Okay, you don't physically see something. The picture box, sure, you physically see it, but we're no longer talking directly to it. We're now dealing with our game item. We're getting you closer to the way you're going to be thinking over in the world of XNA. Just one step closer.
And that gets you farther away from a picture box in that the engine thus far is not dependent on strictly picture boxes. If you came up with some other way of drawing things, like let's say you found a graphics toolkit that had a draw circle function, you could replace the picture box with your draw circle function and the rest of the engine would continue to function just fine.
Precisely. Okay, so just wanted to, I just keep having to hammer this in just to make sure everybody sees what's going on. So back up to the projectile item. We've got initialize, we've got texture, we've got update, and we've got draw. So the next thing we need to do, of course, is to make it all function. We'll go ahead and get check fire. We're going to need to do check air collision. And we don't need call it. I'll just jot that in real quick, Logan.
Right, after we code it in, we need to remember to go back to update, make sure that the collision check is called every time an engine iteration runs.
And then, of course, let's make sure distance is in place because now we need distance. All right, and then all of that will be functioning. Whew, coming right along nicely. Now let's go ahead and move on over to our gameplay real quick. And I know if this seems long, guys, that's why you have the ability to fast forward your videos. How awesome is that? I just like to be as thorough as I possibly can. So in this video, we'll go ahead and call it, well, no, we will not call it edit and undo. Instead, we shall call it gameplay. And what shall we be doing from within gameplay? Well, first of all, we need to remove our temporary reset target call. This is going to seem extremely... This is part of our implementation plan. Go ahead and explain it, Logan.
Well, see, in the last section, once we put together reset target, it'd be nice to see that in action. We want to make sure, test it, make sure it works. but nothing calls it because reset target initially gets called when the game begins. We don't have game logic yet, so we can't, or we're not calling reset target. Though just for temporary purposes, I threw a call to it inside of right after we loaded the graphics, so that way it basically automatically kicked itself off and started running. Now the problem is this section is going to focus on real gameplay stuff, things like begin game, and so we want to make sure we don't have a temporary call to reset target hiding somewhere in the code and possibly causing problems for ourselves later.
Okay. Then we're going to steal, borrow, whatever you want to call it. We're going to steal a few of our methods from Canon 1. There's no reason to reinvent the wheel if the wheel has already been created and there for you to take. What are we looking at? Well, we're looking at begin game, we're looking at end game, we're looking at kill player, and finally we're looking at kill target. So we'll be borrowing these methods from Canon 1. From there, what we'll need to do is comment out any lines that need to be commented because of the new structure of how the code's being laid out.
Right. Most of that code will just directly work. But there's going to be a few things, for example, calls to things like lives that haven't been implemented yet at this point. So we'll temporarily comment those just so that we can build the game and see it running. Because they will do a lot of useful things like, well, make the game able to start and allow the player to die. But they won't work straight out just because of calls to things that don't exist yet.
Right. After we get that into place, the next thing we're going to need to do is go ahead and add game starting check. So add game starting check. Into update scene. I'll go ahead and write that in. Into update scene. So we're going to modify update scene just a little bit so that we can check to see is the game started or not.
Right, we're going to update scene so that it's much like the mouse down event, because the mouse down in the original canon, that was set up to say, is the game running right now?
Right.
If it's not, we need to begin it, and if it is, then we need to fire. It's going to be the same idea. Inside of update, what should we do? If the game hasn't begun, well, don't move things around yet, just have the title screen showing. But if the mouse is clicked on that update, so that's where the check comes in. We do a check and say, oh, if the mouse was hit, then we need to kick off the game start.
Right. From there, we already know that we've got check ground collision and check air collision in place. And since we're now dealing with gameplay logic, we need to go ahead and make sure that we call kill player from check ground collision and kill target from our check air collision.
Right, because again, back in the mechanics section, what we're going to end up doing is just temporarily calling upon reset for the projectile and for the target, just to prove that they're working properly. But what they really need to do is to tie into the gameplay functionality. They need to kill the player or kill the target so that lives get accounted for properly.
If they think all the way back to Canon 1, we did something like that as well. We put placeholders that had to be changed just a little bit once we actually got kill player and kill target into play.
That's right.
And let me go ahead and just add in this last one too. Alright, and this will wrap up that particular video, and at this point we'll have gameplay into place. One thing we're going to be missing, at this point all of our mechanics are there, our gameplay is there, but we don't have any sort of heads-up display. So we don't have our HUD that not HUD, but we don't have our lives display where we can see how many lives we have left. We don't have our start game, or click to begin game graphic up. So what we're going to do next is create a new class. This is going to be our HUD item class. So let's go ahead and just jump over here real quick. Throw in another sheet of paper and hide that. And so this will be our HUD item class. Okay, and with the HUD item class, again, we have got a combination of some private data members, we've got some properties, and we have got, in this particular case, one method. So let's go ahead and jot these in. We're going to have a position, and position will be of type point. We're going to have, of course, a picture box association, and we'll do this just as we did with the game item through texture. So we'll have texture, and this will be of type picture box. Next, we're going to have a width and a height. And these will be of type integer. Okay. Now, these will all be private data members. Squeeze a B in there real quick. There we go. It looks a little bit better. All right, from there, let's go ahead and add in some properties that we can use to access that information. So, of course, we're going to have position. We're going to have our texture. We're going to have our width. And we're going to have our height. And these will all be public properties. And then for our methods, we're only going to have one. We're going to have draw. Now, I think at this point, everything is really just pretty clear as to what we're dealing with. I mean, our position is going to be where it's going to be positioned at. We have, let's find the pin, there we go, position. Our texture is our association with the appropriate texture, or excuse me, picture box. Our width of our graphic, our height of our graphic, and then this is how we're going to be able to set and read or get the information from those data members. And then what is draw going to do? Draw is basically going to set the top, the left, the width, and the height of our picture box for us. So it'll handle mimic drawing, because it's going to be something you'll physically see take place on the screen. So this, of course, will be our public method. All right, and that will be our HUD item class. So this will be a video all by itself, a relatively short one, but it will get the class into place. And then finally, the last video, let's go ahead and come over here and add another sheet of paper. We'll be getting the HUD into use. So putting it to work. So we'll start out by creating our title screen. And this is where we're going to deal with, again, we got initialize, load graphics content, set up draw scene to check for is the game running, and draw the title screen if it's needed, okay, or not. Next thing we're going to need to do is add a call to update player and draw scene in begin game to prevent flicker when it begins. You want to talk about this?
That's more of just a technical thing with the way the order everything is working. See, what's happened is we've created a game item. We need to get our game, or basically we have the player off in the corner. Basically, the player starts at top left, right, because we begin the game instead of updating things. I'm trying to think of a good way to explain this, but we think about update. We had talked about putting a game starting check inside of update, where basically we'll update the player, among other things, or we'll check for beginning the game, either or. That means if we begin the game, we haven't updated the player. If we haven't updated the player, he's wherever he started, which is 0-0 if we've just created him.
Right.
So what's going to happen then, when we begin the game, what does begin the game do? Gets rid of the title screen. So now for a second, or for a split second before the timer hits again, we get to see our player in the wrong position, not in the right place on the screen, so you see him snap to the bottom real fast.
So we see this little flicker. Very good.
So really just making sure that, alright, we're beginning the game, but get all of our game pieces lined up before we actually show the user what's going on.
Exactly. Notice I'm just simplifying this last one. And then we're going to create our lives display. Where, again, we're going to be initializing it. We'll add a new constant in this particular case. Lives display offset equals 4. We need this offset because we need to know where we need to draw out the particular item at. And this is going to be based off of 0, 0 for the item itself, offset it by 4 pixels by 4 pixels. So 4 pixels over from X, 4 pixels down in Y. And what are we going to end up with? We'll end up with, let me find my pen up here, a graphics that's located 4 down, 4 over, just like that.
Right, and the reason we're going to create an extra constant for this is in Canon 1, when we had a simple picture box, we positioned that by hand. We came up with a specific location that got stored along with our form.
Mm-hmm.
In this case, though, we're creating the HUD item ourselves, and we want to avoid a scenario where we hard code in arbitrary positioning numbers. We want to come up with an actual reason for storing this position, and we'll store that in our lives display offset.
Exactly. And then, of course, set up draw scene to check for is game running and draw the title screen if needed, or, excuse me, draw the lives display. So that pretty much gets the HUD all into place. Then what we need to do is get lives display from Canon 1 and rename it to update lives display so that everything flows.
Right,
there.
that's the method that actually looks at how many lives you have and sets the width of your lives display accordingly.
So let me just jot that one in. So get display lives.
And it's really rather simple and functions exactly the same. As a matter of fact, the name is only one character off from already being correct. So the only thing it's really done is to change it, because in the last one it was display lives because we set it and it would immediately update. The difference here is it's called update lives display because that's what's happening. It's updating that HUD item. It's not necessarily showing anything. That doesn't happen until draw. So it's an update instead of a draw. Or in this case, it's update lives display.
And at that point, we will be at the end. And Canon 2 shall be functioning in all of its glory, utilizing a new framework, a basic game engine framework, where we're going to handle polling and updating things within our scene and then drawing those things within the scene, all within a controlled, simulated game loop, if you will. Actually, 2 different loops. We've got 2 different timers, one that's going to be handling updating the items in the scene, the other timer handling the updating of the items' positions, which we're calling drawing in this particular case. Anything else you want to add to this, Logan? I mean, these are the steps we will follow when we code out the game. This is our implementation plan. Anything you want to add?
Not really. I think that will get us to where we want to be, a functioning Canon 2.
Let's see how crazy this looks. Whoa. Yeah. And yeah, so there you go.
So in a nutshell, there you go.
That's it. So, you put these together, then you back away, you stare at it for a few minutes, and you start to see the hidden message of what Canon 2 is all really about. All right, with that, now that we have the implementation plan behind us, I do believe the next video, what we're going to do is take a very quick look at creating objects, and then finally, we'll get into some code. So thank you very much if you managed to sit with us all the way through the implementation plan of Canon 2. And that's it for this video. Thanks a lot.